Welcome back, guys. In this lesson, in this video, we're looking at the double and half angle identities. So you just came from looking at the sum and difference identities and extending that and applying that to actual situations. So you've seen before how we can come up with the double angle identity for sine and maybe cosine too. So if I say sine of 2 theta, that is the same as writing sine of theta plus theta. So they're the same angle measure. So let's use our addition, the sum identity for sine, to see what we get here. So sine, it was sine of the angle, cosine of the angle, and plus in this case. So we have sine of theta, cosine of the second angle, which is again theta. Sines stay the same for sine. And then sine of the second angle multiplied by cosine of the first angle. And so these are all the same angles. So we have sine, cosine, which allows us to say 2 sine theta, cosine theta is our identity for sine of 2 theta. So the double angle identity for sine we have right here. Okay, so let's see what we can do with the cosine. So similar approach. We're going to say a cosine 2 theta is cosine of theta plus theta. All right, so the cosine identity was cosine, the opposite signs of minus, sine. So we have cosine of the first angle, cosine of the second angle, the sine switch, sine of the first angle, sine of the second angle. So cosine times cosine, we can write it as cosine squared theta minus sine squared theta. Right here is one identity for cosine of 2 theta. Now with cosine of 2 theta, we often see multiple versions of this. So how we're getting multiple versions is by using one of our Pythagorean identities. So if I take this identity, cosine squared minus sine squared, if I take this and I substitute, let's say we have sine squared of theta. Oh, we know that that equals what? 1 minus cosine squared? So I'm going to take sine squared and substitute in what we have. So cosine squared theta minus, okay, and with simplifying, we have minus 1. This turns to plus cosine squared theta. So we end up getting, 2 cosine squared theta minus 1. And we have another form for a double angle with cosine. And I'm going to take a similar approach with substituting. Let's say, cosine squared. That's going to be 1 minus sine squared. So we have 1 minus sine squared theta minus sine squared of theta. Okay, so simplifying, we get 1 minus 2 sine squared theta. So why do we need 3? Is there a use for having 3 variations of one identity? I mean, there might be when it comes to verifying, but just know each of these could be used if I have cosine of a double angle. We don't even know what a double angle means or what it looks like yet, but we will. Just be patient. Be patient, guys. Tangent of 2 theta. Again, tangent of theta plus theta. Its identity would say tangent of the first angle plus tangent of the second angle. 1 minus, in this case, tangent of the first multiplied by tangent of the second, and simplifying gives us 2 tangent theta 1 minus tangent squared theta. And we have our double angle identity for tangent. Okay. So have these, write these down. We're going to be using them throughout this lesson, obviously. And from this point forward, we will be able to use this. So that's how can it be used? How can these be used? So let's say if cosine of theta is square root of 5 over 5. So already I'm thinking reference triangle. And theta is between 0 and 90. Find the exact value for sine of 2 theta and cosine of 2 theta. So I need a reference triangle to work with. So we're in quadrant 1. Okay, so cosine, that would say that our adjacent square root of 5, our hypotenuse is 5. All right. Pythagorean theorem, 5 squared equals square root of 5 squared. Call this plus, I don't know, plus y. Sure, why not? Plus y squared. In solving it, we get that y equals the square root of 20. So we have that. We needed that to do this. Sine of 2 theta. Sine of 2 theta was the easier identity. It was simply 2 sine theta cosine theta. Okay? So we have our reference triangle to work with. So sine of theta is square root of 20 over 5. Cosine of theta is square root of 5 over 5, which comes down to 2 times the square root of 100 over 25, which comes down to 20, 2 times 10, 25, which is the same as 4/5, and here we have sine of 2 theta. All right, so let's see what we got for cosine of 2 theta. So cosine of 2 theta, this is the easiest one to have known is cosine squared minus sine squared, so we'll use that one. So cosine squared theta minus sine squared theta. Okay, so cosine is square root of 5 over 5. So we square that. And sine is square root of 20 over 5. We squared that as well. And we get just 5 over 25. And then 20 over 25, which comes down to negative 15/25, which says that cosine of 2 theta now equals negative 3/5. You might be thinking, Mr. Beal, how can we have a negative fraction when none of our lengths here are negative? Okay, well, if that's what you're wondering, how can we have a negative fraction? Understand, we took this angle measure, multiplied it by 2. So when it was in the first quadrant, if I multiply it by 2, what quadrant does it land in? It would land in the second quadrant. So yeah, second quadrant, cosine is going to be negative. Oh, wait, isn't sine positive still in the second quadrant? Yeah, and that's why we didn't really pay attention to it here. But our angle now is in the second quadrant, hence the negative cosine value. Moving on. So what's happening? Oh, yeah, half angles. So we worked a little bit with double angles, just it's a matter of using these identities. So now we have a half angle. All right, so looking at this, sine squared of theta equals 1/2 of 1 minus cosine 2 theta. And a slight variation with cosine squared theta. And tangent, knowing tangent's just sine over cosine, you can see how we got that formula. And you're probably wondering, it's called half angles. Why am I not seeing theta divided by 2 anywhere? What will happen is this theta will be our half angle, because 2 theta we will often know. We will often know what 2 times theta is, which makes the computation here much easier. So now let's examine this. So sine of 22.5. So sine of 22.5. How do we interact with that? Let's see. Well, it's sine squared for the identity, which simply means that at the end we're going to have to square root to get back to sine. That's not bad. That's it, 1/2. Sine is 1 minus. Cosine of 2 theta. So if I multiply this by 2, so let's see what we get. 1/2 of 1 minus cosine. If I multiply 22.5 by 2, I get 45. And this is exactly what I needed. I needed an angle that I could work with. So 1/2, I get excited here. This is going to be square root of 2 over 2. So common denominator, 1/2 of, this is 2 over 2, which says that 2 minus square root of 2 over 2 is what we get. Multiplying by 1/2, so we multiply the denominator, gives us 2 minus root 2 over 4, but that is sine squared. So I foresee maybe that's going to be one of our issues, is remembering that this is sine squared. So sine of 22.5 will be the square root of this. And we have positive and negative being square root. We have to think right now, what quadrant are we in? What quadrant are we in? So sine of 22.5, we are in quadrant 1. We're in quadrant 1. Sine's positive. Sine is positive in that quadrant. So our actual answer will be the positive square root of 2 minus root 2 over 4. So we will have to think of which root we will be using, and it all comes down to which quadrant we are in. Okay, so looking at example 3, cosine of 7 pi over 8. 7 pi over 8. So we want this, we would have, let's draw a line down. So that would be using a different color just for contrast. And these pens are amazing, guys. These pens are amazing. So we would have cosine squared of 7 pi over 8. Okay, so it's going to be 1/2 of 1 cosine's plus cosine of 2 theta. Okay. Knowing that, we just work with simplifying. 1/2 of 1 plus cosine of, let's see, I can do 14/8, which simplifies down to 7/4. Nice. Because we know what 7/4 will be, right? So 1/2 of 1. Cosine of 7/4. We are in the 4th quadrant, which cosine's positive, so positive square root of 2 over 2. And common denominator, that good stuff again, would give us 2 plus root 2 over 2, which brings it to 1/2. Well, I'll just write it again for you guys. Nothing's wrong with that. And so, oops. So we get 2 plus root 2 over 4, and this is cosine squared, which we square root. But which root are we? Positive or negative? Let's think about where we are at. So 7 pi over 8. 7 pi over 8. So I'm 1 short from being 1 pi. So I am in quadrant 2 then, where cosine is negative, so we would use the negative radical. We have to do this step. We have to check to see where we are located, okay? We have to. All right, moving on. Okay. If sine of theta equals 5/7, again, 5/7, I'm thinking reference triangle. And theta is between 90 and 180, so we're in quadrant 2. Find the exact value of these functions. Tangent of 2 theta and tangent of theta over 2, so we're using double and half angles in this. That's good, right? Right? That's good. So we're in the second quadrant. So 5, 7. Let's see. Pythagorean theorem, 7 squared equals 5 squared plus x squared. Coming down, we get 49, 25. Subtracting 49 and 25, we get 24. So x is going to be the square root of 24, but because we're in the second quadrant, x is negative square root of 24. X is negative square root of 24 because of the quadrant we are in. Tangent of 2 theta. We have 2 tangent theta divided by 1 minus tangent of, or tangent squared of theta. All right, so theta, nice. So 2 times tangent of theta. So tangent is 5 over negative square root of 24. All right, that's not bad, I guess. So then we have 1 minus tangent of theta squared. So tangent of theta squared, that's going to be 5 over negative square root of 24 squared. Yikes. Let's work with it. We get 10. Use a different color for contrast for you guys. We get 10 over negative square root of 24. Okay. 1 minus, this ends up being 25. Root goes away, so just 24. But it's still subtraction. Okay. Either in, I think it's actually in the previous video, we were looking at the addition and sum identities. I had said that you can multiply both top and bottom by the denominator to get rid of the fractions. But understand that that was only when the denominators are even the same. And these are not. Do not think that root 24 is the same as 24. They're not the same. So I'm not going to be multiplying by 24 here to get rid of the fractions. So I'm going to have to do some additional steps. So common denominator on the bottom tells that we have 10 over negative root 24. Common denominator would be 24 over 24, which subtracting 2 be, negative 1 24th. Okay, so we're dividing a fraction by a fraction. That's multiplying by the reciprocal. So 24 comes up. Okay. Okay, so in doing that, our bottoms cleared, which brings us to 240 over root 24. Could I rationalize the denominator? Sure, why not? But we don't need to in this video. And nor would I expect you to go further than that. But I am expecting you to not stop up here. Some of you are going to want to be lazy and stop here. We have to go towards the end. Have to. So tangent of theta over 2. So its identity was, well, it's a mixture of sine and cosine. So sine was 1 minus. And then, this is theta over 2. This is theta over 2. Our identities weren't in terms of theta over 2, so that's how we're going to work with this. This is theta over 2, so we have 2 times theta over 2. That's one way to work with it. If this is theta over 2, I place theta over 2 in here. You're going to see something nice is going to happen. 1 minus, oh, the 2's cancel. Just leave us cosine of theta. And then 1 plus cosine of, oh, well, theta. How nice is that? So again, theta over 2, instead of when it was just theta in our identity, theta over 2 just meant I put theta over 2 over here as well, and stuff cancels. So now I can work with it. We get 1 minus cosine would be square root of 24 over 7, and 1 plus negative square root of 24 over 7. Okay, that leads us to 1 plus 1 minus because of the negatives. And this is a prime example of where I can multiply by 7. So I can multiply top and bottom by 7 to clear our fractions, which leaves us with 7 plus square root of 24, 7 minus square root of 24. And we are going to stop here. Oh, guys, how did I forget this? Tangent, weren't all of our identities tangent squared and sine squared and cosine squared? So yes, they were. So I should have had tangent squared here. Oh, how could I forget that? My goodness. So at the end, how that affects it is at the end, this is still tangent squared of theta over 2. So we get the square root. But are we positive or are we negative? What quadrant would we be in? So theta, originally, theta, we can back up, is in the second quadrant. So if I divide theta by 2, if I'm in the second quadrant and I divide theta by 2, we're in quadrant 1 where tangent is positive. And we get here only the positive radical. So tangent of theta over 2 is positive square root of 7 plus root 24 over 7 minus root 24. So a lot of it was just simplifying, but also knowing how to alter our identity, because we had theta over 2 and not just theta. And as you saw my little mess up, but we fixed it at the end, is each of these half angle identities, each of these should be ending with a square root. If you have not recognized that, note that in your note that they end in a radical, and we have to identify which quadrant we are in to know whether positive or negative. Let's end this video with a verify. Verify cotangent of x equals sine of 2x over 1 minus cosine of 2x. So let's tackle this. I like the look of using a double angle. So sine of 2x, oh, that's just 2 sine x cosine x. The double angle formula for sine. And then, cosine of 2x. So here's my thought process, guys. I have a 1 here. Knowing what cotangent is cosine over sine. I have a 1 here that I want to cancel. I want to cancel that 1. So I know cosine of 2x, I had the cosine squared minus sine squared, but that's not going to cancel the 1. So I have my 1 minus 2 sine squared, or my, I believe it is 2 cosine squared plus 1. If I plugged in 2 cosine squared plus 1, yes, my 1's will cancel, but so would my cosine on top, which would lead me to tangent at the end. So I want my cosine to stay there and remove this sine. So I'm going to use my 1 minus 2 sine squared. So simplifying, we get 2 sine x cosine x. Our 1's cancel, and our negative 2 becomes positive 2. So now we have a sine and a sine that we can remove along with our 2's, which leaves us with cosine x over sine x. And we know that to be cotangent. Verified. So we used 2 identities there in that problem, understanding how we had to get rid of the 1. Okay? So best of luck in your practice and your application problems, and I'll see you guys in our next lesson.